Howdy, Bryan Vikings. We're here to talk about phase diagrams. This is day 5 in our solids and liquids unit, and we are going to wrap things up with this one. So let's start by sketching a heating curve and label each phase of matter and the change of state. So let's get iced tea out of here, and let's take a look at what a heating curve should look like. You should have temperature plotted on your y-axis and either time or heat on your x-axis. And you should have a crooked line right here. You should not have any kind of curved lines. And here, between A and B is my solid. Between C and D is my liquid. Between E and F is my gas. Now between B and C is where it is a solid and a liquid. And between D and E is where it is a liquid and a gas. Now, I know that we were working on this in our previous video, and that was your homework yesterday. And if you notice, there's quite a lot of work to do in that. Now, I want to make you all aware that this is mostly bonus material on the test. What's really important is that you have a conceptual understanding of a heating curve that looks like this. And you understand where the solid, where the liquid, and where the gas are. And also you understand that the temperature cannot change whenever we are doing a phase change. So that's why you get these flat lines here. That's the most important part that you take with you on your test. Before I show you what a phase diagram is, I will show you the vocabulary first. The normal freezing point is the temperature at which the liquid and solid are in equilibrium at 1 atmosphere. So that's a normal pressure. The normal boiling point is the temperature in which the transition between the liquid phase to the gas phase occurs at 1 atmosphere. Again, normal pressure. Now, the triple point is the temperature and pressure conditions at which the solid, liquid, and gas coexist as equilibrium. So all three phases of matter are present at the same time. The critical temperature is the temperature above which a substance cannot exist as a liquid. And the critical pressure is the lowest pressure required for the substance to exist as a liquid at critical temperature. So a phase diagram will look like this, and it's really, there's a lot of words on here, and you need to make sure you can unpack all this information. So first, let's unpack the axes. It will show us that the temperature is related to the pressure, and that's exactly what we're talking about. Temperatures related to pressure. And that the solid, the phase of matter that it is in depends on both the pressure and the temperature. Now here we have the solid that's on the left side, and here we have the liquid, and then we have the gas or the vapor. Now the gas is always on the bottom, and the liquid is always on the top right, and then the solid is always on the top left. So now let's point out a couple of important places. The normal freezing point, remember, is at 1 atmosphere and is where it changes from a solid to a liquid. And the normal boiling point is at 1 atmosphere where it changes from a liquid to a gas. The triple point is the point right in the middle where all three of them exist. And it's that point where all three points can meet. The critical pressure is going to be on the top left. That is the lowest pressure, the highest pressure that it can exist as a liquid. And the critical temperature is over here, which is the highest temperature at which it can exist as a liquid. Now, those two combined, a critical temperature and a critical pressure, make the critical point, which is up here on the top right. Most phase diagrams will look like this, but you have to remember that waters looked like this one previously, with the bend in the elbow towards it's bending towards the left. But over here, most of them will bend to the right. So why is water special though? Because of hydrogen bonding. That's right. So we need to make sure that we understand that waters looks different than most phase diagrams for that reason. So just to jog your brain, what phase change would occur if ice is at 0.5 atmospheres and negative 20 degrees Celsius is placed in a vacuum where the pressure is 0.0005 atmospheres? So I need to find out where the ice is at 0.5 atmospheres. Now notice that this is not really to scale, so that's where this would be, is somewhere maybe about there. I'm estimating, and you're allowed to estimate when you do these. And then negative 20 degrees Celsius, again, I'm estimating to about right here. Now, if it's placed in a vacuum, the temperature will not increase or decrease, but the pressure will decrease, and it will go down here. So I'll have to sink it down, and when it does that, I find out what gas it's in. It goes to the gas phase, so going from a solid to a gas is called sublimation. Now, what is the state of matter at 200 degrees Celsius and 200 atmospheres? Again, you just need to find where that point is, find 200 degrees Celsius on the x-axis, and find 200 atmospheres on the y-axis, and wherever that point is going to give you where that substance is, and that's in the liquid zone, so that would be it. Now, what phase change would occur if steam at 300 degrees Celsius and 1.5 atmosphere pressure is cooled to 50 degrees Celsius at constant pressure? So if I have 300 degrees Celsius and 1.5 atmospheres, that would put it right there, and I cool it to 50 degrees Celsius at a constant pressure, I am now going to end up in the liquid phase. So that would be called condensation, going from a gas to a liquid. And then it is then placed in a vacuum at a pressure of 0.1 atmospheres. So I take that same point that I drew, and I need to now go to 0.1 atmospheres, so it falls all the way down to about here. So I'm going from a liquid to a gas now. So now I'm going to have to evaporate it. So I can keep the same temperature, just change my pressure, and I can actually evaporate water or evaporate any substance. Now, what temperature is the normal freezing point and the normal boiling point? You remember those? Remember, normal is 1 atmosphere. So my normal freezing point is going to be here at 0 degrees Celsius, and my normal boiling point is going to be here at 100 degrees Celsius. Piece of cake. Go ahead and take a look at your homework. You need to do phase diagrams, pages 1 and 2. I understand that they are one-sided, so you'll have to work on those, but those are pretty simple. You'll have to make sure that you understand that these are not necessarily water, and you'll have to make the appropriate adjustments. All right, y'all have a good day.